Hello class, we're going to be learning about factoring by grouping today. Specifically, we're going to be focusing on factoring polynomials with a degree higher than 3. Since I believe you guys, the Berry method is technically by grouping as well. But something to review first is going to be perfect squares. All a perfect square is a number that is generated by multiplying the same number by itself. So for instance, 16 is a perfect square because 16 is equal to 4 times 4. Another one would be 4 is a perfect square because 4 is generated by 2 times 2. Another way that we can see this with variables is any variable, say x raised to a squared power, is going to be a perfect square because that's x times x. You can see this with any variable though. It's like a squared, just be a times a. But it doesn't just have to be a squared, it just has to be any variable that can be split up into effectively multiplying by the same number twice. So another example of this could be if we had y to the 4th power. Well, y to the 4th power is equal to y squared times y squared, right? So y to the 4th power would be a perfect square. So any even power will be a perfect square because we can break it down into a variable times a variable that are the same. So like for instance, if we had y to the 100th power, that would just be y to the 50 times y to the 50. Or we'll do one more before we move on. We could have b to the 48th power. It'd still be a perfect square because we could have b to the 24th power times b to the 24th. The reason I'm bringing up perfect squares is I want to review a method with you called the difference of squares. This is a factoring method. It comes from the Berry method, but it's just simplifies down. Similar to our complex conjugates from when we're working with imaginary numbers. Anytime we have, say, x plus 1 times x minus 1, if I were to multiply these together, say we had x times x gives us x squared, x times negative 1 will be minus x, and then 1 times x will give us x, and then 1 times negative 1 will give us minus 1. See how in the middle here, negative x and positive x, those are going to cancel out. This is where our differences method comes from, is this piece canceling. So what happens is this first term, or this first term times the first term here, that's the first square. And then the last pieces, the 1 and 1, multiplied together will give us the last square. So the difference of two squares, if we're factoring it, which is going backwards from the problem we just had, is x plus 1 times x minus 1. Then if I were to multiply these out, the middle two terms would cancel. By the way, 1 is a perfect square because 1 is equal to 1 times 1. But let's do a couple more examples of this. So if we had, say, x squared minus 9. X squared is a perfect square because it's equal to x times x. So we have x plus, we're going to have x minus, all right? And then 3 is a perfect square, or not 3, sorry, 9 is a perfect square because 9 is equal to 3 times 3. So the square root of 9 will give us 3, and that's what's going to come here. Because if I was to multiply all of this out, x times x would give us x squared. 3 times x would give us plus 3x. 3 times 3, negative 3, that would give us the minus 9. Let me erase that real quick. And our last term would be our x times negative 3, which would give us negative 3x. Our two terms in the middle would cancel out, This is where that difference of squares comes from, because this would just be equal to x squared minus 9, which is where we started. Just wanted to show you that's why it comes out to this. But it's always just going to be the square root of the two terms, a plus and a minus. All right, so the general, what we'd write this is kind of like a formula. A squared, so it's a perfect square, minus b squared is equal to a plus b times a minus b. Just heads up, this does not work with a plus. It's only a difference of squares, not a sum of squares. Sum of squares specifically will work with imaginary numbers, but we're not working with those. If we had a sum of squares, those two middle terms wouldn't cancel like we want. That's why it's only the difference of squares that works. Now, back to factoring by grouping. When we're factoring by grouping, we're pretty much taking two of our four terms, or any set of terms, and we're trying to find a group that has something in common. So for here, look at our two terms. These both have an a squared in common. So what we can do is we can factor out that a squared. What's left on the inside, a cubed divided by a squared will be a, minus 3a squared divided by a squared will be 3. Okay, now let's look at what's common between these two. They both have a 16. And I'm going to factor out the negative with it, and I'll tell you why in just a second. So if I factor out our negative 16, let me erase that little piece there. Our negative 16 divided by a is, oh, we're not dividing, yeah, we're not dividing by it. Negative 16a divided by 16 will give us a. Negative 48 divided by, or 48 divided by negative 16 is equal to negative 3. We're just taking it out. It's the opposite of that distributive property. What this does is, you see how both of these are the same. It's a minus 3 and a minus 3. So now we have two big terms, one right here and one right here, that are being subtracted from each other. And if we look and see what they both have in common, is both of them are being multiplied by a minus 3. So once again, we're going to factor, big old parentheses. We're taking the a minus 3 out, it's what we're factoring out. Boop. And on the inside, we have what's left. Our a squared and our minus 16. Cool, so we're almost there. Just the grouping part is going to, we group these together to take out similar pieces, and then we're going to group again. These should be the same. Now, we can still factor this further, because our a squared minus 16 is what we just worked on, our difference of squares. So we're going to have our a minus 3 stays the same, and then a squared minus 16 would be a difference of squares, so we'll have a minus square root of 16 is 4. It's a minus 4 times a plus 4. We can't factor any further, so this would be our answer. Alright, let's do another one. So, let's look and see what we have in common between our first two terms here. Both of them have 5 in there, because 10 is 2 times 5. Both have a factor of 5 in there. And they both have an x squared. So what we're going to do is we're going to factor out the 5 and the x squared. We have 5x squareds coming out. What's left on the inside, 10 divided by 5 is 2. X cubed divided by x squared is going to be x. 5x squared divided by 5x squared will just be plus 1. Okay. Now let's see what's in common between our 4x and our 2. Since 4 is 2 times 2, they both have a factor of 2 in there. So we're going to bring that out. So we have plus 2. And what's left on the inside? 4x divided by 2 is 2x. 2 divided by 2 is 1, plus 1. We notice again, these are the same. So we grouped them together so we could factor. And now we're going to factor again because they both have a term in common. They're both being multiplied by 2x plus 1. So what we can do is pull out, factor out that 2x plus 1. What's left inside is our 5x squared plus 2. Okay. Now, we cannot use difference of squares here because we don't have difference of squares. So we don't have any method for reducing this any further. We just can leave this as it is, and that's our answer. Alright. Now, I want you guys to take a second to give this one a try. Okay, hopefully you guys all got a chance to give it a go. This is our answer here. We can factor out c squared and -1. The reason we're factoring out this -1 is because it makes the terms on the inside the same. And we need those to be the same so we can factor them out here. Alright, so I factor out my 2c plus 3 as well. And we get 2c plus 3 times c squared minus 1. C squared minus 1 is a difference of squares, so we can break that up further. Okay, so this is going to be our last one for today. Let's give it a go. I want you to try this. Give you a second to pause the video here. Alright, hopefully everyone got a chance to give this a go. There was something that was a little bit different here. It's catching you on. So when we were reviewing factoring before, our greatest common factor is going to come out first. So all of these terms have a 3x in them. So we can factor out that 3x first and then work out our problem separately. Kind of simplifies it a little bit beforehand. But once we simplify it, we group up our two sets of terms, take out the x plus 3, and then we have x plus 3 factored out, and we have x squared plus 2 left over. And since this is a sum of squares, we can't quite factor it without using complex numbers, which we will do some of, just not today. Have a great rest of your night, guys.